All right, number two. Now, number two is another definition of the derivative function, right? And there's various definitions of the derivative, and so you could use the one we used on the last one, f of x plus h. Here we have, instead of f, we have g, and instead of x, we have s. But we could use that formula, get the function in terms of s, and then we could plug in the -2, and that would work. And that would give us f primed at -2, or in this case, g primed at -2. And that's one way to do it, to find instantaneous rate of change, right? Because remember, instantaneous rate of change is equal to the derivative, right, at a given point. And so, anyway, that's one way we could do it, is we could find the general function and then plug in -2. Another way to do it is to use a different version of the definition of the derivative, or the instantaneous rate of change formula, which is g primed at a, right, or f primed at a. So I'm adapting it to be g because this is a g function. Well, let me just put the f function just to stay consistent with our notes here. So f primed at a equals the limit as h approaches 0, right? We're using the increment formula. And so it's going to be f of a plus h instead of x plus h minus f of a all over h. Okay, so it's the same thing except a instead of x, right? And the reason it's a little different is because a is going to be a constant that you're given, right? Here in this case, this is our a, right? A equals -2. Okay, and so so what we're going to do to find g primed at -2 is we're going to use this formula, but wherever there's an a, we're going to put a -2. Okay, so it's going to be the limit as h approaches 0 of g of 2 plus h, or -2 plus h, minus g of -2 all over h. Okay, so what I'm going to do off to the side here, and you don't have to show this work, but I'm going to find g of -2 plus h, right, which is going to be this function, but instead of s, I'm going to put in -2 plus h, right? So it's going to be negative, because there's a negative there in front, of 1 over -2 plus h minus 1. Okay, so notice how I put -2 plus h in here in that place of s, right? And so then I can just simplify that. So -2 plus h minus 1, those are like terms there. So it'll be h minus 3 basically, right? So it'll be -1 over h minus 3. Okay. All right, so that's g of -2 plus h. So I'm going to put that in right here, right? So I'm going to put -1 over h minus 3. Okay, and then now let's find g of -2, which is going to be this function, but I'm just going to put -2 in there for s this time. So it's going to be -1 over, and then here's where I'm going to put the -2, right? So I'm just putting that -2 in here where s was before. All right, and then I'll still put the -1 that's there, right? Okay, and now this is a little bit easier to simplify. -2 minus 1 is -3, so it'll be -1 over -3, right? This negative here is still there. And -1 over -3 is just going to be positive 1/3. Okay, so I'm going to put a minus because there's a minus built into the formula here, and then I'll put 1 over 3. Okay, and let me put that in green just to match what we just did. Okay, so that's my g of -2 there. All right, then I'll put all over h, and then I'll put the limit back in. And you don't have to write the limit every time, but I would say, maybe write it at the start and then write it right before you apply the limit. Okay. All right, so now I'm going to do some fraction work here. So we have two fractions. We want to get a common denominator. And so what I'm going to do is I'm going to multiply by 3 here and also on top. And then I'm going to multiply by h minus 3 here, right, to get these denominators to match up. All right, and so now that they match up, now I can combine the numerator. So I'm going to combine all this in the numerator. So it's going to be negative 3 times 1 is negative 3. Minus this negative 1 is going to distribute to both these terms. So don't forget to distribute the negative 1 to that negative 3 there. So it'll be negative 1 times h. And then it'll be negative 1 times negative 3, which is positive 3. Okay. All over. And then I'm just going to keep this same denominator that I have in both these places. But I'm just going to write it once, right? Because we're combining those fractions together. So now this whole numerator turned into one fraction, which is what we want, all over this h in the denominator. Okay. So I'm going to put the limit back here. Zoom out a little bit. Okay. And so now I can see what's going to happen here in the numerator is this negative 3 and this positive 3 will cancel out. So now I end up with negative h over, denominator stays the same. Notice I didn't expand that, right? Because I want to keep it factored, because eventually I want to try to cancel some stuff out. So it's so unless you can combine like terms like we did in the numerator, like that won't be the case here. If we expand it, we'll just be stuck there, right? So I'm not gonna distribute or anything. Although it's not necessarily problematic if you do, it's not really necessary either. All right, so then I need the h on the bottom, so I'm going to put all over h. And then I'm going to put a over 1 here, right? Because now I have this fraction divided by this fraction, right? And when we divide fractions, we want to keep, change, flip, right? We want to flip that guy and multiply, right? Is another way to say it. So what I'm going to do is I'm going to take that numerator fraction here, just write that as it is, but then I want to multiply that by the reciprocal of the denominator function, right? So this denominator function here, I'm going to flip it over. So it's going to be 1 over h. Okay, and now we can see that that allows us to cancel out this h here. So we're going to cancel out the h. This will turn to a 1, right? This will turn to a 1. And so then we'll end up with, forgot to close that parenthesis there, we'll end up with the limit as h approaches 0 of negative 1, right? Negative 1 times 1 on top, all over 3 times h minus 3, right? We're multiplying that by 1. And so we just get itself. And so now we can finally apply the limit, right? So this is where you want to reintroduce a limit. So the two places I like to see the limit, at least one, this would be the best places to show it, I would say. But I would say here and here. Okay, if you put the limit in both those places, that's great, right? You don't have to write it every single time, although that's not bad either. So now I'm going to plug in 0 here to evaluate the limit. And now the limit goes away, right? Because I plugged in 0. All right, so I end up with 3 times 0 minus 3, right? And you don't have to show that work. You can just put 3 times negative 3, right? 0 minus 3 is negative 3, okay? And then from there, we get negative 1 over negative 9, right? Which is equal to positive 1/9. Okay, and let's label what we just got there. So what we just got was g primed at negative 2, also known as instantaneous rate of change at negative 2, right? Okay. All right, so 1/9. And we don't know what these units are. You know, that could be miles per hour, it could be feet per second, it could be meters per second, you know, etc. Any distance over any time. Maybe inches per minute.